Picard iterative method. So suppose we have IVP, derivative of y with respect to x is equal to f of x comma y, shows that f of s naught is equal to y naught. The condition y of s naught is equal to y naught is called the initial condition. You all know what we call an IVP. IVP is an initial value problem. It's an ODE together with what? Initial condition. If you have derivative of this with respect to x having a function of this, and with the IVP, with the initial condition of this, it means that y s naught denote the value of y at s equal to s naught. That is, our s here is s naught, our y is what? Y naught. So the iterative method is a method which consists of a repeated application of exactly the same step. We use the result of the previous step. So it means this Picard iterative method is a method of is a successful method of solving approximation. So when we have a question in form of this, how do we arrive to the steps in solving anything Picard question related to approximation? So these are the steps. These steps from here to the last part is the method, is the step of approximation. So let us consider this IVP. For the IVP, dy over dx, the derivative of y with respect to x, having a function of x comma y, then with the initial condition of this. Dy is equal to f of s dx. For us to consider these steps, we use a separation variable here. That is, we cross multiply. If you cross multiply, we are going to have dy. Then is equal to what? F of s ds. If you cross multiply, we are going to have this. Remember that in separation variable, using separation of method of variable ODE, when we cross multiply, we separate our y part to y, the y to y, and what? The x to x. Then the next step is to what? Integrate. So if we integrate both sides, what are we going to have? We take the integral sign. We are going to have the integral of y naught to y, because we are having what? Y is what? With y naught, then s and what? S naught. So that's what we have for y to what? Y naught dy, then s to s naught for f of s ds. And if we integrate dy, we are going to have y, because d will cancel integral sign, we are going to have y. Then this is what? This is the limit, that is the upper bound and lower bound. Y is equal to what? Y naught. So s naught is equal to x f of x comma y ds. This part, the right hand side cannot be integrated. Why? Because we don't know what f of x comma y is. So that's why we have it like that. So because we know what this one is, this part, the left hand side is for what? Y. So that's why we integrate the y as what? Y. Then if you take the limit part, when y is y, we are going to have this. Minus when y is y naught, we are going to have this. Then it's equal to this, the right hand side. So from here, we have y of x. The reason we have y of x is what? Because y is a corresponding value of what? Y of x. So y or y of x is equal to what? Y naught. How do we get arrive to y naught? I take my y naught to what? Right hand side. Like this plus this. So we have this. Thus, solving one equivalent. So I make this one to be equation 2. So this one is already what? This one is already equation 1. So to finding the function y of x which satisfy 2, since by the differentiating 2 we have this. If we differentiate, when we differentiate all this with the initial condition, we get this one. So this is what the question is talking about. And putting s is equal to s naught in 2 gives this. This is our equation 2. Whenever we see x, we put s naught, we are going to have this. This is s. If you put s naught, we are going to have y of s naught is equal to y naught plus. If we integrate this one with respect to s naught, we are going to have 0. So that's why we have 0 here. So this implies that y of s naught is equal to what? Y naught. And let us try it for what? When y is what? Y naught. Since we have tried for what? S is equal to what? S naught. If you put y is equal to y naught in the integral on the right hand side, what are we going to have? In this integral, equation 2, if you put y is equal to y naught, so we are going to have s is equal to what? Y naught. Because we change y, we let our y to be what? Y naught. So equation 3, where y is the corresponding value of y of x, is called the first approximation. I've explained that before. Y is the corresponding value of what? Y of x. So we call this one as a false approximation. Why? Because the right hand side of 3 replaced by y naught by y1. So we are going to have, if you do it try for 2, we are going to have y2 is equal to what? Y naught plus s naught of x, y of s comma y1 ds. How do we arrive to this? If you have 1 here, if you have yn as 1, we are going to have y1, y naught. Here is what? Yn minus 1. How do we arrive to y naught? It means our n here, if you have y of n minus 1, so 1 minus 1, it will be 0. If our n is 2, I'm going to have y2, y naught, the integral of this from s to s naught, f of s, y1. So that is what we show in equation 4. So we now arrive that if you keep doing this way, the nth approximation of yn is yn of x is equal to y naught plus integral of s to s naught, f of x, yn minus 1 ds. So it means if our n is 2 here, we are going to have y2. Our n is 2 here, y2 minus 1, we are going to have what? Y1, which will get equation 4. So this is what? This is the formula we use when we're asked to find or to show an approximation to solve anything related to Picard iterative method or successful approximation. So this method is called a successful approximation of method, Picard iterative method. And these are the steps we look into while solving the. So we have been given an IVP problem, IVP. So and we arrive to this. So whenever we are given a question related to use approximation method, so we are going to just generate our formula from here and solve it. So how do you get this formula? We get this from the what? The IVP gave it to us. The way over ds equals what? F of s comma y. I hope you find it interesting. Don't forget to subscribe to my YouTube channel.